Hello, welcome to our first online webinar in 2020 with Simone Maffei from Italy, from Modena. It's a great topic today, a very dental technician topic today, digital implant dentistry from a laboratory perspective. Before I pass the word and introduce you to Simone, I would like to take the chance and introduce myself. My name is Holger Kast. I'm the training education head of at TRI, and I'm going to moderate this webinar today. There are certain rules you all can see on the top right side, your toolbar, and during the presentation of Simone, I would like you, if there's questions, please write them all in the toolbar in this part of question, and we will pass the questions at the end of Simone's presentation straight to Simone, and if there's too many questions, we're going to answer them all up via email after the presentation. So this is our philosophy of the TRI implant system. And I would like to take the chance to just announce our five main points of philosophy. So first of all, we are absolute 100% Swiss quality, Swiss-made implant system. With a very big important part, the simplicity. And I think in the presentation of Simone, you were going to see a lot of little details which make a very big difference at the end and make your life in your daily business using a TRI system more simple. And actually the last 10 years in the markets, almost 10 years in the markets, we only changed one part, and this is the Think Digital. I just come back from Paris from the IDD, and we all know that the digital world is not only in the dental technician, and not only the dental technicians have to think digitally, also the dentists and surgeons, they have to really make sure that they are up to date with the digital workflows. And so I just want to keep showing some products of our portfolio. You can see here our digital family, to have different products which you use in the digital workflow. You need to have scan bodies, for example, which I introduce you to our new 3D Touch in a second. We have angulated screwdrivers to bend the screw channel about 20 degrees into the not static zone. We have digital scan implant analogs, as you can see it here, and we have special milling cylinders which are implementing our unique friction connection, which is a very safe abutment implant connection, and also it implements our soft tissue concept, which has a narrow neck to and a consistent emergence profile through all our abutment products, which is a very unique product. So here we can see our 3D Touch scan body, which is basically the combination between two worlds, between the analog and the digital work in your daily business. So it's an open tray impression post, first of all, but it's in the same time a scan body. So you can use this open tray impression post, tie it in. One special thing is also it's without a screwdriver, so you don't need a screwdriver, which is especially in molar regions. You have a very narrow height, and you can use it with this handle, which you can see here in this picture, and you tie it in easily. It will not the threads won't touch the inner threads of the implant before the hexagon connection or the octagon connection in our system is in place. So there's no need for a control X-ray. So we combined a lot of nice features into this product, and then you can do an intraoral scan or an open tray impression post, or both, in this time of digital and analog. But today our topic is the digital workflow. So I think Simone is going to take a lot of time to explain the features of our unique type A's, which is a one tie base. Also here you can see the simplicity of the TRI system. We have one tie base in our portfolio. One is with a 2mm height gingiva, and the other one is with the 0.7mm height gingiva. But in total, you can see here different lines, and as I said, Simone is taking the chance to explain this more detailed. But it's one abutment. In the software, you're going to have 4 different abutments, and one thing is very unique here. It's an angulated part, which is very important for long crowns to have a really safe, stable bonding between the tie base and the crowns which you produce on top of it. Sorry, that was the wrong way. Here, I think it's already time to pass the word to Simone. Please, Simone, you are sitting in Modena in beautiful Italy, and so I pass the word and the rights for your screen to you. Please introduce yourself and go ahead.
Yeah. Hello, everybody. Here, Simone Maffei. I'm the data technician from Italy, and I live and I work also in a laboratory in Modena. It's a small city in the north of Italy. So just switch it. It's okay. Okay, everybody can see, right?
Yes, perfect. I think.
Perfect. Okay.
Perfect. Yeah.
My topic of today is about the digital implant dentistry from a laboratory technician perspective. So from our side, what we can do, what we have to do when the dentist send to us a digital impression, especially on implant. What are we will see some advantage of the product, and then we will see some workflow and different prosthetic restoration. So what are the benefits, what are the advantages using this digital technology combined with a very, very good product. Yeah, just like this, it's okay, it's work. So this slide represents our era, and where we must be ready to think in a new way, because the digital dentistry is reality. So we have to be ready for this changement from the wax up, the traditional wax up with wax, to this digital world. What I can say, it's more mental change than practical, because yes, from the laboratory side, we have just to use this digital technology. You have to learn a little bit something new, but it's not difficult. You have just to switch your brain from the analog side to the digital one. So, and then you will see, and you will get a lot of benefit working through this digital dentistry technology. So today my focus is on about this world. This is the 3 digital implant dentistry world. You have many possibility, many choice, and they cover all the field in implant dentistry. So you can get more info about this world from your TRI dealer, your TRI dealer. You can ask about I don't know, academy. You can find a lot of courses and lecture, so you have many possibility to learning. And then you have guided surgery, CAD/CAM, digital service, everything. It's about this digital implant dentistry. So if we talk about this digital technology, a good question is when we have to use. Here are listed the moments in where digital technology meet with implant dentistry. If we group them, we can define 3 different situations, as you can see. The first one is the virtual pianification. Then we have computer guided surgery and prosthetic rehabilitation step. So when everything is planned, we plan with this virtual instrument, like software for planning, or for the additive technology for creating template if you want to put implant with a digital guide. Then we have guided surgery, and the 3D printer model is the other step, and then we have the prosthetic, the last step, the prosthetic rehabilitation. So from the intraoral impression to the how you can use these components and the CAD/CAM realization of the restoration. So we can say that this digital technology in implantology avoid the mistakes, reduce the risk, and decrease the time of workflow. Another fundamental thing about this 3 digital world is that is an open system. That means the software libraries are available for all software systems that we have now on the market. So this is a very good improvement for the digital world, because you don't need anything more than just ask the library and in an easy way installing your software, and you can immediately start to use this all this system, all this component of this digital family. As probably you know, it's not the same for other companies. So some company you need to ask the library, you have to pay something, or maybe you have to use the proper software. It's not possible to use your software. So in this case, you have completely open system. So we will see now what are the key points, the real important key points for working with digital implant workflow. In this slide are listed the 7 mandatory key points to follow. Once again, the front end of the digital workflow is the digital impression, as you can see on the left side of the screen in the picture, acquiring fundamental information including the scan body. Then this will be elaborated at the CAD software and finally produced. Being in the static area, there will be the need to produce a master model, and we will see why. Always being inside the digital workflow, and it will be discussed which option we have to create this model and how it works. One of the best advantages if you use in a proper way this digital component, and especially if these digital components are produced with a very high quality, is one of the big advantages is that you can work combining model-free workflow with intraoral scanner and monolithic material. All these 3 parts can be used together, can be combined together, and it's possible today. We can say that it's possible today work with this without model, with this model-free workflow. I think you can understand easily what are the advantages if you use this kind of workflow. Especially, you can save money and time, and then you get very precise result. So then it's important to remember when you work with digital workflow, the scan body choice determines which titanium base have to be used. This is very important because when you receive digital impression from the dentist, it's not possible to choose and to use what you want. The choice of the scan body give us an information, and with this info we can use only specific T-base, only specific workflow for following this impression. So matching the virtual scan body is really another aspect of the workflow that may cause small deviation in the accuracy of our workflow. It's then obvious that if the original scan body lacks the quality, this may result in an incorrect matching of the scan body and an error of the position, the analog in the virtual master model. As we say before, the scan body choice determine which titanium base have to be used. You cannot use the scan body from one company and the T-base from another company. Then the titanium base will be cemented in the restoration. So more precise is the joint between this T-base and the restoration, and less mistake we would make during the cementation phase, especially with completely model-free workflow, because we have to bonding the T-base inside of the crown without have any reference, because you don't have the model. So the scan body choice is very, very important. And that's it. If you have very good design of this internal part of the crown that coming from the company, and you use a precise milling machine with good CAM software, you will get very precise result. So it's this step, the bonding step, will be very, very easy. Anyway, we have some cases where we need the master digital model. Yeah, good question is why we have to do this, why we need this. The answer is given by the fact that in the most static case, there is the need to optimize the static. It's not possible to work on single center with monolithic, for example, only pure monolithic. So if you have a static case, we need a support for layering the crown. Then the model will also help us as a support for refining, for grinding, and for polishing our restoration, for checking the occlusion. But from this side, yes, it's just a control, because the occlusion will be planned through the software, will be not retouched on the model, because we are not sure about the precision of this model. So we prefer checking the occlusion and planning the occlusion through the CAD software, and then we use the model as just as a final control. And then we can check the contact point, the contact point, and also we use this model for bonding the T-base on the crown if you have more units, if you have a big restoration. And also we can check if you have to check exactly the position and the contact point during the bonding step. So just a few words. This virtual model can be produced through the two technology. One of them, just I move forward 1 second. This model can be produced through two different technology. Additive or subtractive technology, so you can print with a 3D printer. This is the most easy way at the moment to produce the model and most economic. Or you can mill through the, like we have in the market, gypsum disc for the CAD machine, for the CAD/CAM machine. So you can mill the model, but it's a little bit more long process, and then you have a lot of waste that coming from this milling process. So it's two different ways. So then we go a little bit more inside on the digital family of the TRI implant. We have many options for the treatment. In fact, the TRI dental implant set new standard with the TRI digital as a universal implant interface to leading technology partner in digital dentistry. They offer different treatment options, as you can see here, from simple to complex restoration without limits. So we have the 3D planning and guided surgery. They work with the Mayer software, as you can see here, Materialize, CCAT, Smooth, or 3Shape and Dental Wings. We have the possibility to realize customized CAD/CAM abutment, and here you can see that this is available for all the Mayer software, Mayer laboratory software. Then we have the possibility to do the CAD/CAM cemented retained crown and bridge. So it's your choice. It depends of the planning from the dentist. And then you can choose. You can do CAD/CAM screw retained bars and bridge. So all of them are available for the most used software in the laboratory side. And all these treatment options need some component that coming from this TRI digital family. So we have, of course, the scan body, two different scan body. We have the tree base, where I will explain a little bit more later. This is very, very interesting T-base, titanium base, with a lot of benefit, especially if you compare with the traditional. Then we have angled screwdriver. Can be used for straight or for angled screw channel. So we have the possibility to make more or less all your restoration with screwed and not cemented. Then we have, of course, the multi-unit T-base. They work, of course, on the multi-unit abutment. Then we have the digital implant analog. This is very important in the digital workflow if you have to produce the model, and not all the company have this kind of product. And especially is important also the design of this digital implant analog, because we will see later what happened when you have to put in the model. Then we have the milling blank, as Holger told to us before, where do you have these three friction connection. So the connection is created by the company. There is no mistake. You have the precision and the tolerance that coming from the company. So you are so precise with this connection, and then you design the aesthetic part. You design the part of the abutment from the gingiva to the top. So a few words, I want to say a few words about the digital analog. Of course, you need a 3D printer for create this model. And then on the CAD software, you can design exactly the seat of on the model where will be put this digital analog. So as you can see, you have different benefit that you can use. The design is optimized for conventional and digital use. So you can use also this analog in analogical way and conventional way. Then you can snap into the model. If you print it, it's very easy because the precision of the CAD design, so you can easily put on the model. And then if you want more stability, you can they have a bottom internal thread for fixation, so you can screw from the bottom of your model this analog, and they will be fixed on the model. But honestly, because of the design is conical design, so it's not sometimes it's not necessary work with the fixed analog. So you can just snap on, and you can see have a small friction, and it's very precise. Without small movement, it's work perfectly. Then another component is the tree base. TRI base is a very helpful base for the laboratory, because you have 4 customizing options. So this is the full base, and then you can see this line. On this line you can cut it, and you have the same design on the library. So you choose before to use the base on the CAD software, you choose the height of your base, you choose if you need the angled screw channel, and the design, the mathematics of the design, the CAD design is inside of the software. So when you choose in the internal part of your crown will be exactly as you will cut this tree base. Then another important thing, they have raw turned surface machined for better retention, and it's anodized pink. They have pink color for better aesthetic. So you don't need to sandblast it before going to the bonding step, because this raw turned surface help you a lot on the as a retention for the bonding your crown over the T-base. And then of course it's available like engaging or non-engaging. So you can choose, depend of if are a single crown or if you have a bridge, so you can choose different way. So then when we realized the crown, why we found this tree base very helpful for our daily workflow, because when we have, especially in the aesthetic case, interior area, we choose always this the tree base, DRI base with a very low gingiva profile, 0.7 millimeter, because we won't start with the zirconia restoration more aesthetic as possible. So we won't start from the top of the implant. We don't want to see this titanium base, especially if you are in the aesthetic area on the vestibular side. So we prefer that have full zirconia. So we use this very short gingival part on this T base. So we have talked about some advantage on this T base, and they solve the problem with the traditional T base. And we will see now some sample of this problem that we still have when you use T base from other company. Unfortunately, are not possible always to use the 3 base. Sometimes, as I tell you before, we have to use other T-base from other company because depend of the scan body that the doctor used during the impression process. So the major disadvantage of the T-base that we found on the market are, so the first one is insufficient retention for bonding, and in this case, as we see before, the 3 base, TRI base have rough turned surface from the industry, so we don't need sandblasting. Then a lot of them have insufficient anti-rotation system. In this case, TRI base have 2 flat walls on the 2 sides, so it's more easy for the milling machine create 2 flat walls than a kind of coulisses in your crown. Then most of them have a gray titanium color. This gray titanium color, it's not good for the aesthetic, especially if you have an aesthetic area, if you are in the aesthetic area in the frontal teeth, because if you work with full ceramic crown, zirconia or lithium disilicate, you will see through the crown this color that coming out. So we have to find the solution for try to masking this gray color. And then the last one is undesirable position for HS channel. So not all the system on the market have the possibility to create angulated screw channel. And this is very important, especially in the aesthetic area, but also in the posterior. It depends on the position on the implant. So you can move this angled screw channel, and you can put the screw channel in the right position, maybe in the occlusal side if are vestibular, or in the palatal side and in the anterior if this all coming in the incisal edge or worse in the vestibular side. So here are a few samples of this first advantage. Here, as you can see, we have some T-base available on the market from different company. And as you can see, the anti-rotation system is absolutely wrong. So it's too small. And they have angle, they have squared angle that are impossible to reproduce from the milling machine, or not impossible, but not in a good way. So the crowns made on this basis have for sure a small rotation, a small movement, and this small movement having bad influence on the precision of the cementation, because you cannot see exactly the right position of the crown on the T-base. So maybe if you bond in the right position, in the wrong position, when you deliver your crown, the dentist will have sure some problem about the contact point or about occlusion. Then here a sample of a problem with this gray titanium color. This very old case made in lithium disilicate in 2009, more than 10 years ago. So we glue this monolithic lithium disilicate crown on this abutment, and what we try to do for solve the problem about this gray color, it was applying ceramic opaque on the titanium base, and then over there bonding the crown. This solution we have used this solution for a long time and it's work, but at the same time it's a little bit longer, not easy process, because yeah, we have to do this step. You have to apply the opaque in a very thin way, yeah, and then and then you don't solve completely the problem, because the transmucosal area where do you have the neck still on gray color, still on titanium color. So here another sample, also very old case, more than 10 years ago. In this case, the screw channel coming out on the vestibular side, as you can see on the left image. So the only way possible, because there isn't the possibility to create angled screw channel, the only way possible in this case was using cemented crown. And yes, it's work, it's possible to use, but if you have the possibility to unscrew the crown, to remove the crown in the mount, it's always better. You can check, you can clean, you can do what you want in more easy way. In this case, the crown is cemented definitively on this zirconia bottom. If you have to remove, you need to destroy the crown. It's not possible to remove without destroying the crown. And here, again, 2 years later, still we don't have this angled screw channel, so we have to do this implant crown on the tooth 1-1, the tooth 1, sorry. And again, we have to do, the only way possible it was to do cemented crown, because the screw channel coming out exactly on the incisor edge. So today we have this kind of possibility, this kind of opportunity to angle the screw channel. And if we have to do the same case today, we can do screw with crown with all the benefit that they have. So here a sample of what we can do. As you can see, I think you can see in this image the surface with this micro retention. This is coming from the company. It's machined surface. And you have also this on the left side, on the left picture, you can see the green line. This green line show you what are the cut options. So you can choose different height of the T-base, and you can choose also to cut the T-base with this 45-degree. And this is for angled screw channel, if you have to do this. So all these options still available, and it's very helpful, because you have to you have to use also only one T-base for different 8 different angled screw channels, so different solution. One of the most important things to remember is the cut option have to be selected from the library, because in the library you have the possibility to choose the height of the abutment. We suggest to use always, if are possible, the most higher T-base, the most higher yes, T-base that are available. But sometimes we have less space, less occlusal space, so we have to use the shorter one. Even with the shorter, if you follow the right protocol for bonding the T-base, you don't have any kind of problem. We'll have very good bonding between the crown and the titanium base. As you can see in this picture, this is coming from the CAD. You can see that the internal part of the crown, it's very precise. The design is so precise because it's coming from very good library. Then in the 3RI digital family, we have also this base, the 3-base milling blank, where we have this original 3 friction connection. So it means the connection coming from the company, and it fits so good on the implant, and you have to take care only about the soft tissue part. So you design your soft tissue part, and you design the over of the abutment. You design through the CAD, and then when you put on the milling machine, they don't touch. They don't have any kind of influence on the lower part where you have this friction, original 3 friction connection, but they mill only the upper side. Of course, these are available only on with this titanium blank. It's not possible to do this with zirconia. Then we have also in this digital family, we have the multi-unit in case you have this full mount restoration like a big bridge or full arch. Even here you have 4-8 customizing option. You can choose also from the library. You can use also in conventional way, depends of your workflow. But they have optimized design for CAD/CAM ceramic restoration. So you have just to glue this titanium base inside of your restoration with very great result. And few words now about this angled screwdriver. As I tell you before, is available. This screwdriver is a special one because they can screw they can screw the screw from different angle. The maximum angulation is 20 degrees, but I think is enough for solving the major problem that we can have in the modern in digital implant dentistry. So you can easily through the CAD control your screw channel and position this like in this case, on the anterior case, on the static case, we put the screw channel on the palatal side. So we can get the benefit from screwed crown and in an easy way because everything is planned through the CAD. So after this overview of all the digital family, all the TRI digital family, we will see some workflow. I won't show you just few cases different because they are in different area and with a little bit different function. So the first one is we are in the functional area in the posterior crown. The dentist used the TRI scan body to take the impression. As you can see, the design of the scan body, it's also very important. Because of the position of the implant, sometimes it's too big. Sometimes if you have the implant too close to the natural tooth, this three base, the scan body, sorry, maybe is too big and doesn't work, doesn't fit so good. So in this case, you have the right design to have enough surface for make the matching through the software, and also the possibility to use in almost every case. Here, the dentist send to us the impression, half impression, because it's only one single crown. As you can see here on the left side, these images that are green and yellow, so means that the two, the impression with the scan body and impression without are matched together for having the right position through the through the matching with the library on the scan body. So when this match is correct through the best fit, but I will talk a little bit more about it later. The software automatically put the analog, the digital analog, as you can see, the green one, and the T-base, the replica of the T-base, the design of the T-base on the upper part is the gray one. Then through the CAD software, in a very easy way, we designed our restoration. Here are some steps. As you can see on the left side, it's the analog, the digital analog. You can see the first left, you can see they have two parts where you can put the screw. One is on the top is the screw for the titanium base, and one is in the bottom, and this for fix this analog inside of the model. Everything is inside of the library, so you don't have to take care about it. That's coming out when you design the model, but we will see now. Here our posterior restoration done. So you have different features that you can use on the software, different visualization mode. In this case, we always look with this like this natural color. It's more easy for us to understand and to see if everything on our restoration it's in the right position, it's made correct. Then on the same time, we design the model. So this is also very easy step because the software provide from the impression to create this model with the right height of the base, with the pin for put the occlusion. Usually this kind of restoration single crown posterior area are made without model, so with completely digital workflow. But yes, we have a 3D printer in the lab, so it's very easy to produce a model today, and it's not so expensive. It's very cheap. So sometimes we prefer have it. If you have some doubt, we have more reference and more. Yeah, we can be more precise. Then we mill the file, the STL file, are sent to the milling machine. And in this case, the restoration, it was a provisional restoration. So we mill through the CAD software, to the CAM software, sorry, we mill on the PMMA disk. This is multi-layer. We always use multi-layer for provisional because it's a little bit more expensive than normal disk, but aesthetic is so better. So we prefer to use this way. And as you can see here, our restoration is just milled. We don't have removed, we don't have touched, but we can easily insert the T-base inside of our restoration. This is because the design, the internal design, is really precise. So there is a small friction, but you can push a little bit and you have perfect insertion inside of the crown. Here you can see the crown on the model. It's just sandblasted. Usually, as I show you before, the crown that coming out from the milling machine have a very almost polished surface. It depends, of course, of the strategy, but we always try to do something very good that coming out from the milling machine, because in this step we don't have to touch the crown. Almost we don't have to touch the crown. We have only to remove the pin that keep the crown inside of the disc, and that's it. Then we made a sandblasting with aluminum oxide for create a raw surface, and we finish the crown with composite color. In this case, because it was a provisional, so we paint our crown with this composite color. This composite color provide not only the aesthetic, but also increase a little bit the strength of our restoration, because we apply real composite. It is not like a liquid color. It's a little bit more sticky, and they increase a little bit the flexural strength of our restoration, our provisional restoration. So on the top you can see the three part, the screw, the T-base, and the crown, and in the lower you can see the crown on the model. Then we have to glue the T-base on the crown. This is very also easy process, because the T-base have a perfect fit inside of the crown. So you have just to apply the right bonding, and I will show you a step-by-step protocol for bonding this kind of restoration. Then made a final for the polymerization, and that's it. The crown can be delivered. Here you can see the first the contact point, the control of the contact point, and the crown fixed and with the screw channel closed with the composite from the dentist. And as you can see, for the provision, they work perfectly. It's okay. It's very good. So this is the feedback that we have from the dentist side. So here we see now the step-by-step procedure for the T-base cementation. This is not nothing complicated. It's very easy if you follow, of course, a protocol. Here the provisional cemented. The provisional just milled. As you can see, the internal part is very precise, and the bottom also, where we have the connection with the T-base. We usually, this is the result. We don't have to touch our restoration with the manual burn. We have just to cut the sprue that keep the crown on the disc. Then we use aluminum oxide 50 micron at 2 bar of pressure, and we sandblast the external part and the internal part especially. The external part is for the painting technique, for create aesthetic on the crown with the composite color. And the internal part is sandblasted for have a good adhesion with the cement, with the composite cement, and when we glue the crown on the T-base. So then we don't use a steamer for cleaning because the sandblasted surface can be very, very raw, so it's not easy then remove completely the humidity that we can have inside. We use two specific primer, one primer for the metal, for the titanium, and for the T-base, and one specific primer for the acrylic material. So the metal primer creates very good bonding between the composite of the cement and the metal of the T-base. The acrylic primer creates a very good bonding, very strong bonding between the PMMA restoration and the composite of the cement. So then with this, if you follow this protocol, you have to apply metal primer on the T-base with the brush. Then you apply PMMA primer inside of the crown, and then have to be light cured. Then we apply the cement. So usually we use the same cement that the dentist use in the mount, composite cement, dual, so auto and photo polymerizable. We apply 360 degree around the T-base, the titanium base. We check that if the titanium base are completely covered. Then we put inside the titanium base. We clean in the excess before polymerization because the design is so precise. As you can see, the T-base have perfect fit, so we very easy also to clean. Then we made the final polymerization of this bonded T-base, and we polishing the surface through the color, through this composite color. So that's it. Our crown is ready for the delivery. It's a very simple process. You need more or less 10 minutes for do everything. And if you follow the protocol, you will get perfect result. So just in case, if you have a problem during this cementation, something wrong, you can easily separate your crown from this. Of course, if the crown are in lithium disilicate or in zircon, in case of PMMA, it's not possible put in the oven. Here, a program that I use for separate this T-base from the ceramic crown. The important thing is use very slow heating and very slow cooling, especially for the zirconia, because you know zirconia have very, very bad heating conduction. So here, another very small case in the static area is a lateral crown. This is the provisional situation. Now I move a little bit forward. The dentist take the impression. So we receive the impression, we receive the file. We have to do the match with the T-base, the best fit through the software. Is very step-by-step procedure, very easy step-by-step procedure. And then we do now the copy and paste dentistry. This concept is developed from the Agnini brothers. In this case, because the provisional was okay, the patient liked it so much, so we have just to copy this provisional. And yeah, this is one of the great advantage from this digital technology. You have the possibility to scan the provisional restoration side of the mount to detect the depth, for example, and the superficial contour of the provisional restoration, so you can replicate exactly the transmucosal area and the shape of the crown. This is also possible, of course, analogically in an analogical way, but requires 3 different material and more or less 9 steps, so it's a little bit longer. You need more time and a little bit less accurate than what you can do through this digital technology. So the goal of this copy and paste dentistry is to replicate, copy and predictably replicate the provisional that are tasted in the mounted patient, so are approved from the patient, and especially about the emergency profile. So if you have created good, healthy condition of the gingiva, you need to replicate exactly the same shape on the final restoration. Then we move on the CAM machine, we move on the milling machine. So we realize this crown screwed on zirconia. Then we sintering. Here you can see all the components, the model printed. In this case, because we are in the static area, so we combine the monolithic solution through this skin enamel concept. And the skin enamel, it's another feature that we have developed with the Agnini brothers, with the DDR team. So as you can see here, they work in a nothing difficult. We paint before our zirconia restoration. You can see from the left side, we apply first this neutral paste. Then we apply the color. We create the aesthetic through the color on this zirconia monolithic solution. And then we apply 0.3 millimeter of enamel. We call enamel skin because it's very, very thin layer on top of the crown. This is for get more aesthetic surface and more three-dimensional effect of our color. Here, the crown on the model. Then we have only to glue, following the previous protocol that I show you, the titanium base. And here, the crown in the final restoration in the mount. This was the only one try in, so the patient was happy, the doctor too, so they decide to bonding. Maybe we can adjust a little bit the polishing, the polishing of the surface, because our crown is a little bit too shining if you compare to the natural tooth. But yeah, the patient was happy because with only one appointment they gave this kind of result. So they decide to bonding, and that's it. Also, yeah, I'm dental technician, so every time that I see my crown, I want to redo to try to do better, but not always possible. Here, the last case, just few minutes, 1 minute, 2 minutes, we have finished it. So I want to show you a bridge. This is multi implant restoration, always made through the digital way. The doctor take a digital impression of full arch. In this case, it's very important because we have 3 units. So through the software, we do the same step, the same process. We design our restoration. We get the final file, STL file. And in the meantime, we design also the model. As you can see on the left image, you can see the screw, the hole for the screw with this the analog in the model. So everything is planned through the software in a very easy way. Then we move to CAM process. So in this case, also the doctor want to put a provisional restoration. So we do exactly the same as I showed you before. We mill the restoration. As you can see, it's very precise. It's a sharp milling process. And we have perfect fit, of course, with the 3 base. In this case, we have kept the 3 base original without cut it. So because we have enough height of our restoration. And here you can see the final provision after bonding the base, the titanium base, and after create the aesthetic with the composite color. So we deliver it, the doctor say, okay, everything is perfect, the provisional works very good. So we have just to finish the work. Few months later, we do the final restoration. We have just to remill the same file because the doctor say that it worked. We milled again the same file, just with another material, with definitive material that was zirconia, in this case monolithic, because it was posterior area. So here you can see the painting technique that we use is a three-dimensional staining technique. Yeah, also developed with the DDR team. And that's it. We have to glue it again. The T-base in this case was, of course, non-engaging because we have more implants. And here you can see the final result in the mount. Of course, without any kind of problem because it was exactly the same as the provisional, and the provisional was, the doctor say that it was very good. So we have just to take care about the color, and that's it. So here it's the end of my webinar. I want to say thank you to everybody for your attention. Thank you for staying with me for this me and Olga for this 50 minutes. And I want to invite you to read and to see the other Try Academy online webinar, because you can find always something very interesting and especially free, in a free way. If you have any question, you can write at my email, simone@odontolabmaffei.it. So, or you can ask to your Try dealer for more info about the product. So thank you very much for your attention. Bye bye. See you next time.
Thank you very much, Simone. Very interesting webinar for me, especially because I'm in my heart and in my background dental technician. So it's always good to get an update from the daily business of somebody who is really using components which we develop at TRI, and get a feedback of it. I had some questions from Bulgaria, from a friend of mine, a dental technician in Bulgaria, Ivano, and he was asking about the bonding, because you were mentioned, okay, only sandblasting. We were talking actually before we start the webinar about it, because I was just like with the Anini brothers in Italy, in Paris on the IDD, and there was a very interesting presentation about the bonding on tie bases and what is the right way to do it and how you do it. And there's one very important point that as you mentioned, that our tie base has this rough net surface, this meshing surface. And they made a lot of tests or they showed these tests how is the best bonding, and there's a lot of primer and stuff you can do. And actually it came out that 50 Newton centimeter 50 micron sandblasting would be giving a very good result. And or when you have a meshing treatment as we have it, it gives you also the possibility to not sandblast it, because you can keep the red color in our case, a pink color in our case, and have a bit an aesthetic plus. And so that was, maybe I just answered that question. What was the other question regarding? Sorry, I have to check that again. It was about the screwdriver, exactly. The screwdriver, the anglet screwdriver. If it is, it was also a question I can answer, because it was if it is in the normal surgical kit. No, the anglet screwdriver you have to order at TRI at your dealer, especially to use it, and it's always in combination with the software. Then from my side there was a question. When you do this 3-unit bridge at the end, it was a really nice case. So you have a PMMA, and you use the tie bases, and then do you do another priming for the PMMA, or another process for PMMA priming or bonding combining to zirconia?
Yes, we have a specific primer for bonding the PMMA with the composite cement. So they create a very strong chemical link between the PMMA molecule and the composite that we use for cement. We use as a cement. And if you have zirconia, the final restoration, you have to use a specific primer with MDP technology. I think we have a lot on the market from many companies. That can create a good link between the good bonding between the zirconia restoration, the oxide of zirconia, and the composite that you will use for bonding, that you use as a cement. So we don't have a specific recommendation. You can choose what you want on the market. Many companies, they produce cement, composite cement, and bonding. The only suggestion that I want to say about the cement is using dual cement, auto and photopolymerization, for photopolymerizable, because sometimes when you have like in the molar restoration, you have big thickness of zirconia. Even if this zirconia is translucent, it's possible that maybe the light don't arrive on the internal part so good with so strength. Depends also on the lamps that you use, which kind of light you use. So for that reason, we prefer using the lamp for block the cement, but then waiting 5 minutes because the cement have this auto polymerization system. So we prefer always use this two-way cement.
Okay.
Okay, to be
There's
sure
another
that.
question. Oh, sorry.
Yeah.
Sorry.
Yeah, no, it's okay.
There's another question from Svetomir Ivanov from Bulgaria. Hi
Yeah.
from my side to you. He is asking, which is I think a very good question. If you have a 3-unit bridge and we have the non-engaging tie base, and he asked if it is a good idea, which some people do, to use one with a hexagon or one an engaging tie base and the other ones with a non-engaging. So if you would combine it, or if you would do for a 3-unit bridge only engaging one. I get this question actually very often, and I would like to know what you mean about that.
Yeah, you can do this. You can use one engaging and the two non-engaging. Usually, when we have a bridge, we always use non-engaging. We don't find a benefit to mix the two kind of T-base. It's possible fixed one if you want fixing the mount. Maybe it's better if you use the first one engaging with the hexagon and the other non-engaging. But this is only if you want bond this T-base in the mount. So in our experience, we have seen that if you have a very good CAD design from the company, like your library, you get very precise and good result from the milling machine. So if you glue not directly on the restoration, not on the model, we have seen that the result it's okay. When the doctor doing the X-ray in the mount, our restoration have a perfect fit always without any kind of problem. Of course, this depends. This kind of result coming from the impression. So it depends how the doctor take the impression, if doctor have a good experience or not, because we have seen that we have many digital impression on the market, many intraoral scanner from a lot of company. What I can say about it is that almost all of them work, but they need a dentist with a good experience for work in a proper way. So the difference is coming always from the human side, not from the machine side. Okay.
Good. There's a lot of more questions coming in. I say hello to Portugal, to Hugo. He just says amazing presentation and thank you to you. Then there is in the chat right now Andrea Nini, and he says his greetings as well. We have more questions to answer, but we're running out of time. I guess the hot topics I will pass to you later on. We go and answer these questions via email. There was one question more about high polished from this was from the Arabics. Who was that? 1 second.
Dr. Salman.
From Dr. Salman. You can see it exactly from Dr. Salman. He was asking about high polished or machined, and I was answering it already by writing, so that's why I can't see it anymore. Hi, Dr. Salman, please go ahead, answer this last question, please, Simone.
So they ask if it's better having the transmucosal junction high polished or regular polished. So in my opinion, everything that is inside of the mucosa, inside of the alveolo, okay, from the head of the implant to the neck of the restoration, had to be really polished.
Absolutely agree.
But in this case, the surface are machined only on the part that have to be glued with the crown. So the neck part of the T-base are very good polished, so you don't need to make another mechanical polishing. Usually, we prefer create the transmucosal area with the restoration, especially with zirconia, because with zirconia we can have very perfect surface after mechanical polishing, so we can get like a mirror surface, mirror polished surface. And this is the best way because the gingiva love it a lot when you have a polished surface, especially with zirconia.
Okay. So, Simone, I say thank you again to you. I just want to take the chance to announce our digital festival in Cascais in beautiful Portugal, close to Lisbon, on the 25th to 26th this year. Where we're going to have a very hot topics about the digital dentistry, about all the digital workflows. You are going to be involved with a live surgery with the Anini brothers as well, and there's a lot of things. Please stay tuned. I think this is one of the biggest topics we are talking about and announcing at this festival. It's the world first digital implant, the Matrix. I can't explain more in this presentation today, but I think we are working here on the future of dentistry, of digital dentistry. So I would like to say thanks again to you, and stay tuned for the next webinar. It will be in March, and we announced that soon on our social medias. Thank you very much for listening to everybody. Remember, to touch it is to love it, and stay tuned. See you soon. Thank you.
Bye bye.
Bye. Bye-bye.